Good afternoon, good morning, and good evening to everybody. Welcome to our Waters webinar today, where we are going to be going over some really exciting work in the seized drug space. So our title today is Leveraging the Radian ASAP in Standard Casework, Insights from Industry Experts. So my name is Rachel Lieberman, and I am the Global Forensic and Toxicology Market Manager here at Waters Corporation in the Clinical Business Unit. And I will be your moderator today. We have three amazing speakers here, as you can see on the screen. But before we get started, what I'd like to do is give you guys a little bit of an overview of the platform and get you guys familiar with what you're seeing. So here is the look of the platform. When you are looking at this, there will be a Q&A box where you can ask any questions throughout the webinar. And then at the end, we will have a Q&A session where you are able to, we will take some time to answer them, and you can specify which member you'd like to have answer. In the center, you will see the slides for the presentation. Below the slides, you will see any resources that are relevant to today's topic. And this can be applications or links to websites, etc. On the right-hand side, you will find the speakers' bios and a survey. Please feel free to fill out this survey at any point during this presentation. We use this information to make sure that we are providing appropriate information to you guys. And if there's any additional topics that you guys want to see as the year goes by, please let us know, as we're always looking and taking that into account. We'll also be conducting a few polls throughout the presentation just to gauge the audience. So be prepared for those. And if at any point you're not able to see any of these windows that I'm describing, there are icons at the bottom, and use those to click and expand these particular windows. So as I mentioned, we talked about some polls. So let's get started with a poll. So I know we have a handful of different people from a variety of different places. So one question that I have for you guys is, what tests do you guys currently use for your preliminary screening for seized drugs? So we have immunoassay, chemical assay or test strips, color testing, Raman, a handheld device, FTIR, or TLC. And you are able to select more than one if you'd like. I'll give you guys a second or two to answer this, and then we can take a look at these results. And this will also help us as we go through the presentation and our speakers to really know where we want to target our discussions. So we've got a few people coming in. All right, here we go. We got a few more. 8. Making sure everyone has got their coffee or drink of choice for this long webinar. All right. So we'll move forward. All right. So it looks like we have a kind of a mix. Oh, and Radian was on there. My apologies. I could not see that on my screen. So it looks as though we have, most people are using color testing for their screening, few FTIR TLC, and we do have one that is currently using Radian. So that's exciting. And so when you guys are doing these tests, the next thing that I'm curious about is, what are the emerging drug trends that you're seeing in your region? So are there specific drugs that are common in your area, some that maybe you don't see, or do you see things that have multitude of drugs, a combination together? Give you a couple of minutes to, or maybe 30 seconds or so to look at this. Again, you can select more than one answer on this one as well. So I'll give you about 15 more seconds. There we go. And we're going to touch on a handful of these different drugs during the presentation today from our panelists. So this is good to kind of see where we are, maybe where we need to expand and so forth. All right, another 5 seconds, see if we get some more responses. All right. So, all right. Well, panelists, as you can see, everything. So handful of xylazine, fentanyls are still prevalent, nitazines, a few are seeing ketamine, benzos, and then a lot where you're seeing a multitude or combination of these. So this is good information. So thank you guys for your participation in this. We really do appreciate it. And so with that, I'd like to introduce our speakers. So first we have Emily Lee, who is currently an application scientist at our Winslow Labs in the UK at Waters Corporation. And she's a part of our global team and specializes in forensics and toxicology. So she has gained experience in the use of various Waters mass spec technologies and has been our go-to person when it comes to the Radian ASAP instrument. Previously, she also had experience working in forensic toxics labs prior to coming to Waters. So she will be leading off today's presentation. Following that, we'll have a brief presentation from Dr. Patrick Sears, who is currently a senior lecturer of chemistry and forensic analysis at the University of Surrey in the School of Chemistry and Chemical Engineering. His research expertise and background include developing analytical chemistry solutions for complex problems and understanding how analytical systems can be broken down to improve precision and accuracy. He currently chairs the Ambient Ionization Interest Group of the British Mass Spectrometry Society, and his main research focus is how these techniques can be used to address a diverse range of applications, including drugs of abuse, explosives, environmental pollutants, and pesticides. And then finally, Karen Lau will be speaking to at the end. So she will lead up the last presentation before our Q&A. And so she started her career in drug analysis back in 2015 as a forensic scientist at the North Carolina State Crime Lab. In 2022, she joined the Wake County Crime Lab, where she continues to perform analysis on seized drug evidence. She is certified by the American Board of Criminalistics and Drug Analysis and has over 9 years of experience performing controlled substance analysis and has completed over 6,000 cases to date. So with that, I'm going to turn this over to my colleague, Emily. Emily, can you start over?
Yeah, thank you. I just saw that. Sorry. So I'm Emily Lee, and I'm just going to go over how the Radian ASAP works, and then I'll pass on to Patrick and Karen, who are the users of this. So as I said, I'll be covering how it works, how to use it, and how to view the data and the results. So first, analysis with the Radian ASAP. So Radian ASAP, it stands for Rapid Direct Analysis Atmospheric Pressure Solids Analysis Probe. And it's a small footprint instrument which really combines the simplicity of ASAP with the specificity of mass spectrometry. It's been designed for rapid, easy, and low cost per sample analysis, and has already shown great promise as a screening tool for seized drugs with no chromatographic separation needed. How does it work? First, I'm going to cover the ASAP ionization process. So the sample is initially introduced into the instrument on a glass capillary, and this is introduced into the corona discharge region. Here, there is a stream of heated nitrogen which serves two purposes. Firstly, it provides the heat source for the glass capillary, which volatilizes the sample and then creates the gaseous molecules. Secondly, it creates nitrogen plasma in the region around the corona discharge pin, which is the basis of one of the predominant mechanisms of ionization. the nitrogen plasma indirectly creates ions from the volatilized molecules, which are then guided into the instrument. So the main mechanisms of ionization for ASAP are really identical to those which are seen with APCI. The first of these mechanisms is a charge transfer mechanism, which is initiated by the corona discharge ionization of the nitrogen in the source. This generates radical cations of nitrogen, which can then undergo charge transfer with the analyte molecules to generate the radical cation. This form of ionization is particularly useful for the analysis of nonpolar compounds and typically is more prevalent in in-source conditions without the presence of protic solvents such as water or methanol. The second mechanism for ionization is by proton transfer. This requires the presence of water or other solvents such as methanol. These can act as a source of protons to form the ionized solvent clusters as shown. The ionization of the analyte then occurs by proton transfer, which is the main ionization pathway associated with APCI and LCMS. So now I'm going to cover the single quadrupole mass spectrometry, which is used with the radiant ASAP. So once the sample has been ionized, it enters into the ion guides and the quadrupole. The radio frequency and direct current voltages are applied to the quadrupole, which create a fluctuating field. Opposite rods have the same charge applied, and this alternating field guides ions based on a mass-to-charge ratio. Mass data can be collected in two modes, either full scan mode and static mode. For drug screening, we have been using full scan mode. In full scan mode, the radio frequency and direct current voltages are scanning transmitting ions in sequence. The quadrupole can scan an ion in milliseconds. More ions are transmitted in scan mode than static, but the sensitivity will be lower, and therefore it is ideal for screening. The data required can be viewed in a TIC, and the individual mass-to-charge spectra can be extracted. So how do we sample the analytes? So a dipping technique is usually used. So normally we would have a seized drug sample and we would dissolve that into methanol. And then for each sample, a glass capillary is dipped into the solution for approximately 5 seconds at 1 centimeter depth. And then this is placed into the ASAP source where data acquisition is automatically triggered. So I just have a short video on the next slide, which shows this in motion. So I'll let you watch that and then I'll be back.
The Radiant ASAP is a compact mass spectrometer and has been specifically designed to be very easy to use. Samples are analysed directly, without chromatographic separation and with minimal preparation. Samples for testing can be crushed, or in the case of powdered or crystalline material, we can simply take a small amount of sample into the vial with a common solvent such as methanol. And then it's a simple action of pipetting or dipping the sample onto a clean glass capillary and loading that sample into the Radiant ASAP for direct analysis.
So from that video, I think you can see how easy and quick the Radiant ASAP is to use for seized drug samples. Just want to check, Rachel, can you see the slides again now? Okay, perfect. So now I'm going to cover the data acquisition and how you can view the results on the Radian once you have them. So the data is acquired in positive ionization mode. Mass detection is performed using full scan MS over the range master charge 50 to 600. To further enhance specificity, the data is acquired simultaneously over 4 different cone voltages. This results in fragmentation and the generation of both the precursor and product ions for the compounds. So here on this slide, we have an example of ketamine CRM, which was acquired on the Radian ASAP. So the acquisition of the 4 cone voltages creates a spectral fingerprint. The identification of a compound is based on the identification of the precursor ion, which is present in the lowest cone voltage, and in this analysis, that is 15. So you can see that ASAP ionization has resulted in the generation of the protonated species at 238, which is ketamine. And then you can also see as the cone voltage ramps up, you're getting more fragmented ions as it goes along, creating that fingerprint. So for the data processing, we use library matching through LiveID software. So this can be done in real time where the data is processed whilst the sample is still running, or you can process the files post-acquisition. Software is very simple and easy to use. It doesn't require any scientific expertise to interpret the results. And the software calculates an average match score of the data against the C's drug reference library using a reverse fit model, with a greater weighting being placed on that precursor ion in the lowest cone voltage. We've used a match score of 850 as a threshold to indicate a positive identification, and this is out of a maximum match score of 1000. So on this slide, we have the current C's drug reference library. It currently contains 78 compounds. This includes common drugs of abuse and cutting agents. We have updated the library recently to include synthetic cannabinoids, synthetic opioids, particularly nitazines, and also xylazine, following the emergence of this compound as an adulterant. It is possible for users to add to this reference library or to create their own custom libraries to contain the specific compounds that they require. And here we have an example of the LiveID results for the ketamine, the CRM that we saw previously. So the sample was analysed in triplicate, as you can see from the 3 responses which are in the top left panel. And then in the panel on the right, the spectral data is shown. The acquired samples data, which is shown in yellow, is matched against the reference spectra of the library, which is shown in blue. And you can see that's for each of the cone voltages acquired. So the individual match scores are calculated, and then the weighted average is calculated from that. So for here, in this example, we have 997 for ketamine, and as the maximum match score is 1000, this is a very good identification. So thank you for listening to my part. If you do have any questions, please place them in the Q&A box and we'll get to them at the end. And now I'm going to pass over to Patrick for his talk.
Hello, thank you very much. Yeah, I'm Dr. Patrick Sears, as was mentioned, and the talk I'm giving primarily is talking about some of the background work that I've done on the Radian, and maybe giving you a bit more of an understanding as to what else the instrument can do, and therefore how it can be used to help us. Just in terms of my background, yeah, I am a chemist. I have gone out into industry. I've worked in a range of different fields. Eventually, I ended up doing forensics, working with the UK Forensic Explosives Laboratory. And since then, I moved to the University of Surrey, where I work primarily on mass spectrometry. As was mentioned, I'm chair of the ambient ionization group for the British Mass Spectrometry Society, and this is where I first came across radiant. So within my lab, we have a range of different areas of interest where we use radiant to help us. So we start off with, we did some work on food. We've looked at using radiant to help us with the identification of meat, looking at adulteration, authenticity in a range of different products, from olive oil to turmeric, trying to understand exactly how radiant can help us with these kind of challenges. From there, we moved on to looking at education. We've used it for a range of research projects. So I have a number of research students in their final year of their undergraduate course doing projects with us. But at the same time, we were also taking this instrument into a teaching lab to our first year students here at university, and getting them to experience mass spectrometry and being able to use it for everyday challenges. It really is that easy that students can use this even very early in their scientific careers, and it's great for introducing them to a range of different things that you can do with mass spectrometry. I have a student working on this, looking at pesticide detection within the environment. We're also looking at a number of other types of material that cause problems within the environment. And then in terms of forensics, we've done projects looking at ink extracts, looking at ink analysis. I have a student at the moment looking at fingerprint aging and exposure of fingerprints to other chemicals, and how we can use this radiant mass spectrometer to answer some of these. But the majority of my background was actually in explosives. I've done an awful lot of work looking at different types of explosives. And radiant we can use in the same way that Emily's just described, looking at scans to understand exactly how explosives ionize. On the screen here, there's an example for a material called HMX, which is a fairly high-end military explosive. And we can get a fingerprint from that material, which actually helps us understand exactly how it ionizes and gives us a really good basis for understanding then the selectivity that we get when we analyze this material. We can go from doing scans to actually using single ion monitoring. And there we can manage to get a much higher sensitivity, because we're spending all of our time then looking for the material we're interested in. If we start looking for TNT, we've been able to actually see down in the femtogram level of sensitivity materials from surfaces. It's absolutely bonkers that you can do that with this instrument that is so quick and easy to use. I really don't understand quite how we get that level of sensitivity, but nevertheless, it's definitely there. We can also use this for doing detection of explosives. So we can look at the transfer of material between surfaces. We can put this into airport detection type scenarios. And I've had first year students being able to do practical demonstrations looking at 1 nanogram of material on a surface, being able to transfer that using a piece of material, transfer that onto the glass rod that we typically use with the radiant, and being able to see 1 nanogram with a good detection, and in the 20-30 seconds that it normally takes for an analysis. However, explosives aren't really why the majority of people are here. We're more interested in looking at pharmaceuticals and drugs. So we are doing quite a lot of work in the pharmaceutical space, understanding how the ionization works, doing library building with this, looking at solid sampling. Can we just rub our glass sampling wand onto the drugs that we're interested in, transferring material from there straight into the radiant, but also understanding what normal looks like. So if we have a pharmaceutical tablet, what represents normal? How does that look? Can we understand when somebody has got something which isn't normal? Can we understand counterfeiting? How can we work in that space? I am noticing a whole range of questions coming through on the Q&A. Any which are specifically directed towards me, I'll pick up once I've actually finished talking. So I'll come back to some of those and answer people directly. We are also working on the toxicology space. I've recently completed a project where we've been looking at understanding and analyzing materials directly from toxicological matrices. Here we've been doing some work using the radiant for drugs of abuse from oral fluid. So we've been collecting samples using a fairly sample swab, transferring that via a pre-concentration onto the end of the rod, and then being able to analyze it. And what Emily showed you very nicely was how quick and easy it is to get the sample into the mass spectrometer. The bit that didn't come out maybe from that video was how quick the analysis is after that. So you saw the rod being inserted into the mass spectrometer. You typically get a response from the instrument in about 3 or 4 seconds, and the analysis is generally over within 20 seconds. It can be really quick and really easy to get that data out of the mass spectrometer. And we then get, sort of really specific ions. We can detect a number of different ions from each of these materials. We can do targeted analysis. So I mentioned about doing SIM. That we can do simultaneously for all of these analytes. In fact, the UK drug driving panel has about 18 analytes on it. That works really nicely for us. And it gives us the ability to be able to detect simultaneously these analytes and at a range of different limits of detection, getting down towards the parts per billion level, which we need to be able to do if we're going to meet the UK requirements for drug driving. I have to say I'm not aware of exactly what the limits of detection are for different jurisdictions. This gives us a much higher sensitivity than SCAN, but we do lose something in terms of the being able to see everything at the same time. Here, we'd only be looking typically for 18 or 19 analytes. Now, the Radian isn't actually that repeatable. Most of that repeatability is actually due to how we introduce our material into the instrument. But you know what? That doesn't actually matter. In any of these analyses, despite the fact you can see here, we've got big ones, we've got small ones, we've got faster ones, we've got slow ones. But all of those would actually give us the same answer in terms of the material that we're looking for. And we can actually understand exactly, sort of the material that's there. So what question are we answering? Well, if you're answering, is this material there or isn't it? We'll get the same answer every time. We can get some degree of linearity. So you can see here some data from a SCRA material, which was looking down towards the limit of detection. And even here, we can get a linear response if we add the material in the right way. We can do detection of material directly from infused papers. So this was XLR11 being directly sampled. We just wrapped the glass rod on the paper, and we were able to get a signal, even though that paper actually only contained 50 nanograms of the material. Typically, certainly in prison scenarios, we see way more material on a piece of paper than that. We can also do linear materials. We can get a nice calibration curve, and especially if you put an internal standard in there, you can do that. So you can introduce that by means of dissolving your material up in a solution which already contains your internal standard. We can do that with matched internal standards if we're really that bothered. We can do surrogate standards. So here we were using quinine as our internal standard just because that wasn't going to come up in any of the materials we looked at. You can do replicate analyses. That helps us narrow things down and get more consistency in our data. It is somewhat analyte dependent, but you know what? We did this. We compared it with a absolutely gold standard LCM SMS analysis using a really well-known method, and our uncertainties from the two methods directly overlapped. It wasn't giving us any great penalty. So we can do a whole range of different analyses. I need to thank a whole bunch of people. They're all up here. I'm working with a great bunch of people at Waters to do this work. We're working with SpectralWorks, who are developing new software for this system going forwards. Rommel gave us really good solvents to enable us to do that work. And a lot of this work was conducted together with one of our national measurement laboratories, which is LGC. And I need to acknowledge them for their help and support as well. So at this point, I'd like to thank you very much for your attention. I will be handing over to Karen. I'm happy to take any questions in the Q&A, and I'll be available later for anybody who needs to ask anything further. Thank you very much.
All right, good morning, good afternoon, good evening, everybody. As Dr. Sears said, my name is Karen Lau. I work as a forensic chemist at the Wake County Bureau of Forensic Services in Raleigh, North Carolina. And I'm here to share with you today how we've incorporated the Radian into our workflow and show you some examples of some of the fun things that we've gotten in our lab. So just as a brief introduction, the lab that I work at is a county lab in Raleigh, North Carolina, and I'm one of 2 full-time drug chemists. We receive all types of evidence, including your normal powders, glassine bags, scissors, and your not so normal fentanyl kilos and pot suitcases. Last year, we completed 882 cases and worked almost 6,000 individual samples. But I'll refer back to this number a little bit later. The methods that we use to analyze our seized drugs are color tests, microcrystalline tests, macro and microscopy for plant material, FTIR, GCMS, and as of 2021, the Radian. The Radian has become such an integral part of our workflow and is used for all types of case samples, solids, liquids, tablets, everything. Here's an example of how it would be used in a typical case. Let's say that this is an off-white powder. I would take a tiny amount of it, place it in a glass vial, and dissolve it in methanol. At the instrument, I would first run a solvent blank, which is what you see on the left. Then I take the capillary and I dip it to my sample for a second. And after it's introduced to the instrument, a peak is generated. Then I integrate the peak at each of the 4 cone voltages and obtain the mass spectral data for my sample. And when I first look at Radian data, I look at that 15 cone voltage, which is all the way at the bottom, and I look for the M+1 ions in my sample. And I can see that this one contains a 337 and a 281. After my sample is done running, I then use LiveID to search my sample against our in-house library, which contains 196 controlled and non-controlled standards. LiveID then uses, LiveID then uses reverse matching. LiveID then uses reverse matching to compare the ions in the library standards to the ions in the sample. It assigns a score out of 1,000 for each one, with, again, the 1,000 being a perfect match. So for each one, it produces a graph that illustrates those ion comparisons with the ones in your sample in yellow and the ions in your library in blue. Since we only use the Radian in a preliminary screening capacity, we have to do additional testing to confirm any controlled substances. The sample was run on the GCMS, which then did confirm the fentanyl and the ANPP that was also seen with LiveID. And with that, I have 2 positive tests for each component in my sample, and I was able to obtain mass spectral data for multiple components, and that's more information than I would have gotten with a traditional color test or any other preliminary tests. My hands-on analysis time for a case like this can be as little as a few minutes. Sorry, these can be as little as a few minutes, and what lab doesn't like to be efficient? I'm sorry for these the slides seeming to jump ahead of me. Okay, so let's get into the fun stuff. As Dr. Sears was talking about earlier with normal tablets and not normal tablets, we get a lot of not normal tablets in Wake County. These are our M30 tablets, and I can easily say that we've gotten tens of thousands of these tablets through our lab, even just last year. And I call them typical because I can probably count on one hand how many times I've had them where it actually contains oxycodone. So for these typical M30s, the straight methanol runs show us that these tablets contain mostly acetaminophen, and the acetaminophen standard is on the right, so you can compare the 2. Because the Radian doesn't have a separation component, I have to separate out those components myself with a base extract into hexane. This process removes the acetaminophen from the sample, and once that extract is run on the Radian, I am able to see the other components of my tablet that were previously hidden. So again, we're going to look at those M+1 ions. I can see a 337 that corresponds with fentanyl. The 299 corresponds with despropionyl fluorofentanyl. The 281 corresponds with ANPP, and the 355 corresponds with fluorofentanyl, which are all seen by the LiveID software. So of the almost 6,000 samples that were analyzed in Wake County last year, almost half of those belong to hypergeometric cases. And that means that we've run almost 3,000 of these types of samples because that's generally what we're using our hypergeometric cases for. Lately, our M30s have somehow gone off the deep end, and now a lot of them contain BTMPS, which is a light stabilizer used to protect plastics and coatings from oxidation caused by weathering. And who doesn't want to put that in their body? I have an example of a straight methanol run on the left, and the BTMPS standard is on the right. Even with a base extract into hexane, the BTMPS does not go away. It isn't until I zoom in on the mass spec data that I actually see the 337 and the 355, which again are my fentanyl and fluorofentanyl in my sample. These tablets have been a very unwelcome surprise from the last half of last year through now. However, there is still something that we are able to analyze using the Radian and provide that data for each individual component. Another type of sample that I want to share with you today are nitazines. The Radian has become such a valuable tool for samples like this because there really isn't another quick way to screen for these types of compounds. This also makes the Radian really good for things like benzos and synthetic cannabinoids. Within a few minutes, I can take these weird-looking green M30s and see that they contain metanitazine. However, this particular sample also contained fentanyl, and I have the red arrows there to kind of point out that little blip where the 337 is hidden in the baseline. Since I don't have that separation component on the Radian, I had to run 2 samples on the GCMS for this hyper to confirm both substances. And that is one downside of the Radian, is that when it's overwhelmingly something else, it becomes hard to see the smaller components. The next type of sample I want to cover are benzos. Even though these are typically lower in concentration than our M30 friends, we can use the Radian to easily screen for traditional and designer benzos. So here's an example of one of our most popular benzos, bromazolam. This has become such a huge time saver for those hypercases that contain benzos because I can quickly run one sample on the Radian and throw the other one on the GC without having to worry about finding and running any standards or waiting for a screen run to see even what I'm working with. Another benefit of having the Radian is that we can run a sample and in a few minutes see numerous, sometimes unrelated compounds all with one test. This is one of my favorite examples from casework that demonstrates how useful that can be. And as we're all getting a whole bunch of different combinations of drugs, this is a really good illustration to see that in that 15 cold voltage, I can see multiple different N+1 values and then associate them with all of the compounds that LiveID sees as well. So for this sample, we have 8 different compounds ranging from fentanyl and heroin to mannitol and xylazine. And that's just not something that you'd be able to tell from traditional color tests or any other preliminary tests. We've also used the Radian to help us with isomer determination. So here are N-ethylpenolone and 2 of its isomer friends, and N-dimethylpenolone and N-methyl N-propylmethylone. I've focused on the N+1 ions for the other examples, but that isn't really super helpful when we're dealing with isomers and those numbers are all the same. However, we can use the data from other cone voltages and see that even though there are similar ions present, there are also some distinct differences that are highlighted in yellow. And we've used that to help us identify the isomers that are present in our sample. The Radian does have some limitations though, and it can't separate other isomers like fluorofentanyl or methylfentanyl. So just to touch on a few more quick examples, we've had some success with thermally labile compounds as well. This example shows the difference between 2CB and 25B NBOH. These standards are underavatized and just dissolved in methanol, so you can see that they are visually very different and easily distinguished. We've also had success with things such as THCA and pregabalin. Sorry, my slides are jumping again. THCA and pregabalin, and we are able to see those on the Radian easily, and they appear to be unaffected by the high heat of the analysis. Fentanyl and beta-methylfentanyl have nearly identical GCMS spectra, but we can easily identify which one is which using the Radian by comparing those different N+1 values. So the N+1 for fentanyl, again, is 337, and for beta-methylfentanyl, it's 351. We haven't seen beta-methylfentanyl in casework yet, but it is helpful to know that we are able to distinguish it using this method. So the last example that I want to show is for one of these magic mushroom chocolate bars. We performed 2 separate extractions on our chocolate bars, one with acid and one without. And we run the extract without acid on the Radian. A majority of the chocolates that we analyze do truly contain psilocin that you can see from this sample on the screen. However, we have had a few that contain acetylpsilocin, and we don't know whether they've been sitting around for too long or they just weren't made very well. But that is something that we are able to see using the Radian, as psilocin and acetylpsilocin look very different. So just to wrap things up, the Radian has become an irreplaceable tool in our workflow. Our method is only a minute long, so to run a blank and a sample only takes a few minutes. Because the instrument is so sensitive, we really only need a tiny amount of our sample for each run, which makes it really useful for residues and other low concentrated samples. The Radian produces mass spectral data and in turn reviewable data for the sample, which makes it a lot less subjective than other traditional preliminary tests such as color tests. There are a few things to keep in mind though if you are considering the Radian for your lab. Since there's no separation component, samples that are overwhelmingly one thing, like BT-MPS, it may be difficult to see smaller components in that sample. We also use the Radian for almost every hyper we do, but running 20 plus samples all at once does require a longer hands-on time than just running a color test and throwing them on a GC. So each hyper takes about 2 hours, but the data that's generated from it is worth taking the time to do. The Radian also requires a nitrogen source. For us, it has been more cost-effective to use a nitrogen dewar. However, a nitrogen generator is also an option. Overall, the benefits of having the Radian far outweigh any of these things, and we are happy to have it in our lab. With that, thank you so much for your attention. I'm happy to answer any questions that you may have in the Q&A session. Thank you, everybody.
Thank you, Karen. And let's go ahead and have Patrick and Emily jump back on as well.
Hi.
Hello. So this will be the start of our Q&A session. And what we have up here is just everyone's contact information, myself included, in case if we are unable to get to all the questions that were asked today. So we really appreciate it. I apologize because my cat is in the background, so you guys can just listen to that. Hopefully it will quiet down. And then we really appreciate the questions that you guys have asked so far. And I know we haven't maybe answered a few directly, but I will get that started. And then if you have any that come up, please feel free to put them in here. We've got plenty of time to get through these. So one of the first ones that did come through is someone had asked if we are able to provide certificates for the webinar. And I just want to mention that now, yes, if you guys need a certificate of attendance, please send us a message and let us know, and we can provide one for you if that's needed for your own background. So one of the first questions that came in, and I think I'm going to tailor this one to Emily to start with, is does Waters provide their library, and can you add a drug to the library or start your own internal library?
Yeah, so it's free for download on our digital download website. And then, yes, you can add drugs to it. There is a white paper that I wrote, which basically takes you through step by step of how to do that. all you need is to download. It's a freeware, so it's a software you can just download for free off the internet, and you input your MassLinks raw data into there, and it converts it into a way that LiveID can read as a library. It seems hard to do when you read it, but once you get in the hang of it, it's really simple and quick to do. So yeah, that's how you would do that.
Yeah, and I will, and also there was a question asked about the LiveID software. And do you want to also follow up on that as far as that it comes with the system as well? So
yeah, so that one, I think you need a license, but I think that it does come with the system. It's included with the package.
And yeah, and you'll get a link to the digital delivery platform where you can upload the libraries and any new additional ones that we may have or provide free of charge for the libraries. So perfect, thank you. So this, and Karen, you guys also have created your own libraries too, correct?
Yeah, so we run all of our in-house standards on our library. So everything that we, all the standards that we have run, we can say we've run it on this instrument. And when we run our samples, we can say they were run on the same instrument for comparison purposes.
Perfect. So hopefully that answers that question. And I think there were a few questions that came in as we went through about, have we analyzed mixtures in the evaluation? And I think we covered those, especially in yours, Karen. But one question that did come in was like, how concentrated are the samples? Have you ever experienced where you've like saturated and what do you do if that maybe is the case?
Oh yeah, we've saturated some samples. Typically with powders, it's easier to kind of control that because you're using really just the amount that you'd use for a color test. So you're not using a lot, but sometimes when we have things like liquids or sometimes oils, it does kind of saturate the instrument. And at that point, we either change the capillary or just kind of clean it out a little bit and then everything as well. But yeah, we're still able to see all of those components even with a saturated sample.
Okay, great. And actually, I do want to make a quick comment. I think in the resource list, we should have that white paper that Emily mentioned. But if not, it is available on our website as well. So it should be easily found for those that have questions about how to add to the current library. And so moving forward, I'll get back to this other question here in a second. One question here, this is, I just answered that one from Nicole. So I think this is specific for Patrick. We have a couple here. So concerning meat identification, do you identify markers or do you build databases for each type of meat?
Yeah, so this was, what we did was we used the Radian in a scan mode, and we looked at effectively the lipid profiles that were present from the meat. So we did a very quick extraction in hexane, which I think probably answers somebody else's question. Shook it up with hexane and then just dipped and analyzed. And we built a library based upon, in fact, we built models based upon the different responses we got from a range of different meat samples. And then we could use it to distinguish between chicken, pork, beef, lamb, duck, and turkey. So yeah, it worked really quickly. It was a fairly extensive model, so we had about 1,000 samples within the model that we built. But that was that took a few hours. So yeah, it wasn't very difficult to do, and that model was then valid for sort of weeks afterwards. It wasn't dependent upon the mass spec on that particular day, and could still distinguish between different types of meat.
Okay, yeah, that's really interesting. And on top of interesting types of matrices or different things, what about is this applicable to any kind of hardwood samples, such as like bark or bamboo?
Okay, so to that one, I can't speak directly, So I know that you can use ambient ionization mass spectrometry to look at hardwood and softwood. I was speaking to somebody not that long ago who was using it, looking at illegal trafficking of logging from South America. And so, yeah, definitely we can use this type of mass spectrometry. I haven't seen anything done directly on wood by ASAP. I have seen somebody looking at seeds and looking at being able to differentiate between different types of seeds using it. So I think that would probably look for the same kind of markers from within the seed casings as within wood. So, yeah, I can't see any reason why it wouldn't work, but I just haven't seen exact examples.
Okay. Karen, have you looked at anything that is not like powdered based or something like that? Do you guys see any of those kinds of substances that come in, or is it mostly already in a package or powder?
A majority of the things that we get are, your typical case seized drug samples, so powders. Liquids will also run on the Radian. We'll do a small drop in methanol, and that works really well too. In terms of weird things, papers, we do get papers from prisons. Works really well on the Radian because you really don't need a lot at all. I don't really know that we get too many weird matrices. The chocolate's kind of a weird one, but we're able to extract that out. We have had some strange things that we think aren't controlled is also helpful on the Radian, because if there's not a peak, then that's just another indication that there might not be something there.
Right. Exactly. Well, and speaking of extractions, someone, Nicole, asked about the magic mushroom edibles. What type of extraction do you use for that particular sample?
I don't remember exactly where we referenced this extraction from, but it's basically we have 2 samples and we're doing a water bicarb chloroform to one with some chloroform washes in between to kind of get rid of those, like the fats and the sugars and everything. And then we do one with water, acetic acid, bicarb, and chloroform. And the reason why we separate the 2 is because if there's acetylsalicin present, we don't want to add acid to both to create then the psilocin. So we do 2 separate ones to make sure that the psilocin that we have is truly psilocin and not just being converted from acetylsalicin.
Okay, great. Thank you. And so I think you answered this, but I just want to double check that you did, because we've had a few more questions come in. Nicole Martin had asked, what's the experience with the overloading of samples? But it sounds like for the most part, you mentioned you can still see it, and if need be, you're able to kind of rerun, right?
Yeah, so when it's overloaded, the peak, instead of looking like this, kind of looks a little fatter, or it can tail. But you can still integrate those peaks and see the ions that you want. It's just a matter of, after the sample runs, you want to clean the capillary off. The instrument does have a bake-out function where it heats the capillary up to 600 degrees Celsius to clean that. So typically that's enough, but when the sample is over-concentrated, you can switch out the capillary, get a new capillary, or wipe the capillary with methanol and like a Kim wipe.
Okay.
Yeah, I guess just to come in there, I mean, we use a fresh capillary for each experiment. They are standard melting point capillaries. They're a few pennies each, so it's not a big deal to have to change to a fresh capillary every time.
Yeah, and I think that kind of goes into Buzz has asked a handful of questions here. One is, how often do you have to do more sample prep to distinguish components in a mixture? That's for you, Karen, and then also like, what some of the routine maintenance it is to clean the instrument. So in terms of additional sample prep for multiple components, really the one that we're doing the most is that water-based hexane to get rid of the acetaminophen, because that is the majority of what we see. When there are sugars present, and it's mostly sugar, we just typically go and throw the sample on the GC with a chloroform wash to kind of get rid of that. In terms of maintenance, we don't switch out our capillary every time, but we know that it's clean because we run that solvent blank before every sample.
so we can still be confident that it's not like a contaminated capillary. Every once in a while, every 6 months maybe, if the baseline starts getting real big, I open up the instrument and just kind of wipe out the little source enclosure. Nothing big. I'm not taking the whole thing apart, but it's just as a little maintenance to kind of clean up anything that might be in there. But that's really it. It's really a low fuss instrument for us.
Yeah, Emily, what other maintenance do we recommend or require beyond the fact that, you know, the standard single quad maintenance that you would want on an instrument?
I'm the same as Karen. Like, I've never really had to. I use the bake out function, and I run methanol blanks like at the start of like a sampling session, but like that's about it. Like, I've never really had to do much to like clean it or anything like that. Like, it's pretty robust.
Okay.
I guess my students are a bit more messy then. So we have to do periodic, as Karen said, just wipeouts of the inside of the source enclosure. I think we probably do it a bit more regularly than that. And obviously, an annual PM does certainly make sure that the instruments are remaining clean inside and tip top. But yeah, we're not seeing any great degradation in performance on a day-to-day basis, certainly.
Great. Thank you, guys. That's really insightful. And Dr. Sears, another question for you. So can you expand more on the system about the trace residues that are transferred to the probe rather than in solution?
Absolutely. So we've been looking at a range of different ways of doing this. One of the main ways we've been trying to do is trying to make it familiar to people like airport security officers and customs officers who are very used to using ion mobility spectrometers at the moment, and for that they generally use a flat swab of some kind, a swipe. I think they generally refer to it in that area. So we've been using those same kind of swipes and then just wiping that onto our rod afterwards. And even though that must be a really lossy transfer process, I think we're probably getting about 10% transfer. But because of the sensitivity of the instrument, that's not proving to be a problem. So, that experiment I described where a student put 1 nanogram onto a surface, he just rubbed that with a normal swipe, which is used on an IMS instrument, transferred that by wiping it onto the glass rod, and off we went, and we got an immediate response that was plenty big enough to detect.
Okay, great. Thank you. And we do have a handful of a few more questions coming through, and hopefully we can get to all of them. We are reaching at the top of the hour here soon. One question that I think could be answered by all of us that is, we had someone that asked if there's a chance to potentially tour a lab or be able to walk through. And I'm not sure if this means, come into a water site to see it, or, if they're local to you, Patrick, or even Karen, but is that something that is potentially a possibility? We can talk offline too.
For me, that's not up to me, but I can ask.
Yeah. For anybody in the UK, yes, I'd be more than happy to host people here. And I would imagine the same, your local Waters sales rep would be more than happy to talk to you about coming to visit a Waters site.
Yeah, if you have questions, reach out to someone and we can definitely follow up down the path on that. And following up, there's a question about, are there any future plans to add an auto sampler? And I think that that's awesome and would be ideal. But what I'm aware of right now is at this current time, no, just because of the design of how the ASAP source works. But it can be something potentially looked at down the road. So if anything changes or anything, we will let you guys know. And so let's see, what other questions can we ask really quick? So I think this is interesting, and I'm not sure, the exact answer to this, but what would a validation look like for your lab? So if you're going to look at a specific validation, and this may be tailored more to you, Karen, what would that look like?
I wasn't here yet when this instrument was validated, but I can tell you that we ran the quinine, which is what actually we use for our QC check every day. So we ran that a few times for reproducibility, just to make sure that that's working fine. I know there was a comparison where we ran case samples, but then also compared that to GCMS data to see if they agreed. And I know that was a part of it. I'm sorry, I don't have all the details on it.
Okay.
But that's at least, we did at least do that part.
Okay, sounds good. Well, we are just a minute past the hour, and I know we weren't able to get to every question that was asked, but we can follow up on those afterwards. I do want to mention 2 quick things for those of you that are located in the US. The beginning of April, there is the AASCLD or ASCLD meeting in Denver, Colorado. We will be there with Irradian. So if you are interested and have some questions, please stop by and we can talk to you about it. Additionally, May 8th, we will be doing a workshop at the SAFS meeting, and Karen will be doing a 2-hour like hands-on demo for the Radian. So if you're local, that's in Jacksonville, Florida, and are able to attend, that'll be a great way to also get some hands-on experience and ask direct questions. So we really appreciate all of your questions today and your interest. And we wish we had more time, but we don't want to take it all. So I want to thank all of our speakers today. You guys have been fantastic. And you guys for your attention. And with that, hope you have a great day and we'll see you soon.